Here you can see there are three sections: multi-compression, multi-evaporator and cascade system. What are the need of multistage system? That is given here. You can go through it, right? Then in the first section, that is the multi-stage compression system. First point is the two-stage compression with flash gas removal. Okay. In this, what we are doing, we are using the two compressors, single evaporator, single condenser and two expansion valve. This is the flash chamber from where cold vapor is mixed with hot vapor of first compressor and intercooling happens. And then collectively we are sending it to the second compressor, then to the condenser and then to the here in the flash chamber. From the bottom of flash chamber we are collecting only liquid and vapor we are sending it to the for desuperating. Then that collected liquid sent to the second expansion valve and then to the evaporator where it will absorb the heat and cycle repeats. Right? This is the pH diagram. 1 to 2 is what? Compression is isentropic compression in first compressor. 2 to 4 is what? Intercooling in the flash chamber. Right? 4 to 5 isentropic compression in second compressor. 5 to 6 is constant pressure condensation. 6 to 7 expansion. 7 to 8 is what? In the flash chamber, liquid refrigerant is collected at the bottom and then it is expanded 8 to 9. Then it is sent 9 to 1 is evaporation and cycle repeats. Right? Here you need to write what is M1, what is M2, what is M3, formula for M1, M2, then formula for refrigerating effect, formula for power. Here you can write divided by 60. Okay? P2 divided by 60. P1 is what? Power required for first compressor. This is for second. Total power. COP is what? 210 divided by 210Q divided by P into 60. Formulas are almost common. Okay? Only M1, M2 formula will differ. Now, in multi-stage compression, second is what? Two-stage compression with liquid intercooling, or it is also called as flash intercooling. Now, what is the difference between flash gas removal and flash intercooling or liquid intercooling is that after desuperheating, after first stage of compressor, when we are sending it to the flash chamber or liquid intercooler, whatever the output we are getting at point 3, that is saturated vapor. Right? That is saturated vapor. You can see this on pH diagram. Process 1 to 2 is what? Compression in first compressor. 2 to 3 is what? What is 2 to 3? Intercooling. And where is the point 3? Saturated vapor. Right? That is the only difference. Okay? 3 to 4 second compression. 4 to 5 condensation. 5 to 6 is what? Expansion. Right? And cycle repeats here. Okay? Here you can clearly see that even though two expansion valves are used here, directly you can take it straight line. Okay? Till now, okay, that we will discuss later on. This is the schematic diagram and this is the pH diagram. Okay? And same thing that this formula M1, M2. Now, if it is asked for 5 marks, you don't need to write too much. It is just for your understanding so that you can solve the numericals. Okay? As per marks, you need to write it. M1 is what? Refrigerant in first compressor. M2 is what? Refrigerant circulated in second compressor. M3 is what? Refrigerant evaporated in the liquid refrigerant evaporated in the flash chamber because of superheated vapor from the compressor 1, and that is equal to M2 minus M1. Right? Now this M3 can be calculated by using the energy balance equation of flash chamber. M3 कसा काढायचा आहे? How we have to calculate M3? Mansi. What is M3? M3 is what? M3 is what? Here, M3 is what?
Mass of liquid.
Yes, mass of liquid refrigerant evaporated in the flash chamber. मग एनर्जी बॅलन्स इक्वेशन कशाला ऍप्लिकेबल आहे? फ्लॅश चेंबर. एनर्जी बॅलन्स इक्वेशन म्हणजे काय? एनर्जी इन इज इक्वल टू एनर्जी आउट. नाव लुक ॲट द फ्लॅश चेंबर. व्हॉट इज एनर्जी? आतमध्ये काय येतं आणि बाहेर काय जातं? लुक ॲट दिस. सो व्हॉट इज एनर्जी? मास इंटू एन्थाल्पी. नाव यू कॅन likewise you can calculate the mass m3, how much liquid refrigerant that will evaporated for desuperating inside the flash chamber. That's why it is very very important to have the high latent heat of evaporation, right? If refrigerant don't have the high latent heat of evaporation, what will happen? Most of the liquid refrigerant will evaporated in flash chamber itself. What is our target? Our target is evaporator, not flash chamber, right? That's why such a systems are suitable only for the refrigerant which has the high latent heat of evaporator, like R22 and ammonia. Ammonia is the mostly suitable for this. Okay? Ammonia is fantastic refrigerant. It has very good thermodynamic properties, physical properties, chemical properties. It has only one drawback, that is it is toxic, right? But it can be detected. That's why in industry, even after 100 years, ammonia is primarily prepared. Means or other refrigerants, ammonia is, they are taking ammonia for refrigeration till now. They are using since last 100 years. Okay, so this is the energy balance equation. Energy in is equal to energy out, and from this you can calculate m3. Okay, and you can write down the refrigeration formula, then work required, or directly you can write down the, instead of writing this work formula, you can write down the power formula, right? Power is just work done per unit time. Okay, and COP, formula of mass. Okay, in air refrigeration system also, and here also, here only M1 M2 like this is there, right? In the air refrigeration system only M is there, right? So formula of mass, that is M1 M2 M3, refrigerating effect, power and COP. Okay, here whatever I have discussed about latent heat of evaporation and refrigerant, that information is given here. Okay. Now third, that is the two-stage compression with water intercooler, liquid subcooler and flash intercooler. In syllabus, that is in the first section, last point is what? Complete multistage system. Complete means what? It has subcooling, water intercooler, flash intercooler, everything, right? Schematic diagram, you can see it. Look at the schematic diagram. Evaporator, then compression in first compressor, water intercooler. Now why we are using water intercooler here? So that amount of refrigerant evaporated here will be less, right? Then it is sent to second compressor, condenser, and after condenser we are doing the subcooling. Condensation is both process different. In condensation we are converting only vapor to liquid, and in subcooling we are cooling further up beyond the saturated liquid line. That is your subcooling. Here you can clearly see subcooling 6 to 7. 1 to 2. Now tell me the process. 1 to 2 in first compressor. 2 to 3 water intercooling. 3 to 4 flash intercooling in the flash chamber. 4 to 5 isentropic compression in the second compression. 5 to 6 6 to 7 7 to 8 expansion. Then at the bottom of flash chamber, then second expansion, right? Okay. Then these are the processes, whatever the processes that you can elaborate. Then what is M1, M2? Mass circulated in first compressor, mass circulated in the second compressor. So here M2 is equal to what? M1 plus mass evaporated in the flash chamber. M3 is not taken, okay? Because see here, if you don't take M3 here, but you need M3 for calculation, right? refrigerating effect, power and CO. Same point. But look at here, power. Two powers are there. M1 into H2 minus H1 plus M2 into H5 minus H2 divided by 60. COP is refrigerating effect divided by W. That
210Q.
here 21Q divided by P into 60 or formula in terms of this. Right? That is about multi-stage compression, where single condenser, single evaporator, but compressors are two. Right? Now second section, that is the multi-evaporator system. In multi-evaporator system, single condenser is there. Now the main purpose of multi-evaporator system is what? What is the main purpose of multi-evaporator system? Main purpose क्या है? To achieve the different temperature at different location. Multi-evaporator system म्हणले की डोळ्यासमोर काय आणायचं? demarked. Different temperature at different location. At dairy product, different temperature, right? At normal grocery, different temperature. That is achieved by using multi-evaporator system, right? And this multi-stage, this multi-pressure system is suitable for big units, right? Big units can be handled by using multi-pressure system, right? Now here in multi-evaporator system, see here, first single compressor, individual expansion valve. Compressor is what? Single, and expansion is individual. Individual expansion means separate expansion valve for separate evaporator, right? Now just look at this compression, after compression sent to the condenser. Here, see here all of you. This is what? 5 to 7 is what? 5 to 7 is what? First evaporator. And 4 to 6 is what? Second evaporator. And what is this back pressure valve? What is the purpose of this back pressure valve? Or it is also called as PRV. What is PRV? Pressure reducing valve or regulating valve. Right? Now here, why we are reducing the pressure? Because only single compressor is used, and suction pressure of compressor should be same. But input of compressor is not only one evaporator, it is two evaporators. So output of both evaporators should have the same pressure. But is it same? Look at this, output of evaporator 1 is what? 7. And output of evaporator 2 is what? 6. Clearly here is the pressure difference. So is it possible to send this refrigerant to the compressor? Not possible. That's why there is a back pressure valve or pressure reducing valve or pressure regulating valve. Then we are reducing the temperature. Here also we are using the expansion only, because there is no any other way to reduce the pressure, right? Here we are reducing the pressure by using isenthalpic process. So enthalpy at 6 and 8 same, right? Then here from pH chart we can calculate enthalpy at 0.7 and we can calculate enthalpy at 0.8. Do you remember this? All of you? And how we are calculating the enthalpy at 0.1? Average. Tell me that formula here. H1 is equal to, tell me.
M1
Yes, M1
H7
S7 plus
H6
M2 S6 divided by M1 plus M2. Right? Average म्हणजे काय? 7 चा average आणि 8 चा average. 7 ला एनर्जी काय? M1 into S7. Here काय? M2 into H8 divided by M1 plus M2. As simple as it is. Right? That is H1. And H2 can be calculated from pH chart. Okay? Here I am discussing about numericals only. Numericals are asked for 10 marks. But without understanding theory, you cannot solve numericals. Right? Yes. So here you can see look at how individual expansion valves are. How you can recognize it is individual expansion valve? Because output of expansion valve 1 is sent to the, see here, numbering you should give the properly. Here, if it is evaporator 1, here expansion valve should be the 1. If it is here evaporator wall 2, here expansion wall should be the 2, so that you will not have any confusion. Okay. Now output of this expansion wall is supplied to this evaporator wall. Output of this expansion wall is supplied to this evaporator wall. That's why individual expansion means separate expansion for separate evaporator. Right? Here write down the formula of M1, M2, power formula, H1 formula, important one. Then COP formula. Here directly you can write down 210Q divided by P into 60. Common formulas are there. Okay. Formula of work is given here. You can refer it later. Okay. Schematic diagram, pH diagram and formula. If theoretical question is asked, read the question carefully. Understand its meaning and what is expected. In numerical also, read the question and after given data, first what you need to do? pH chart. If your pH chart is right, your entire numerical will be right. If there is some mistake you will make in the pH chart, there will be some mistake in the numericals. I am not saying that entire numerical will be wrong. Okay. One more strategy you follow in any exam. Whatever you know, you write that first. Right? And whatever you don't know, don't skip. Write something at the last. Okay? So that you will get few marks. And don't attempt, if you have attempted question 1, don't just delete the question 2. Before selecting, take lot of time. Take 2 minutes for selection. But after selecting, some students now in this unit test also, some boys and girls use the strategy that they know question 1A, they solve question 1A, they solve question 2B, 3A, 4B. They thought sir will not recognize. How I cannot recognize? I have set the paper. I am checking. Don't think that examiner will by mistake forget and you will get the marks. It will not happen. Okay? And definitely you will not have extra time to attempt the additional question. That's why choose the question carefully and then don't write optional question. तुम्हाला ऑप्शनल क्वेश्चन मधलं किती जरी येत असलं तरी लिहायचं नाही. आणि जो क्वेश्चन तुम्ही सिलेक्ट केलाय त्यातलं काहीच येत नसेल तर काही ना काही लिहायचं. ठीक आहे. This strategy is only for weak students. Others should ignore this. Now next. Stop your strategy discussion. Look at here. Next, single compressor, multi-expansion wall. Compressor is single. Multi-expansion wall means what? Output of for some evaporator, output of both expansion wall is supplied. Right? Now here look at this. See here. Output of this expansion wall is supplied to the evaporator 1. Right? Evaporator 2. And look at the input to the evaporator 1. It is supplied with output of expansion wall 1 as well as expansion wall 2. That's why this system is called as multi-expansion. How schematic diagram is differ. Look at here how schematic diagram is differ. Look at the position of this expansion wall. Right? Then compressor and condenser. In multi-evaporator system, wherever single compressor is there, at that time we require this back pressure wall. Okay? Here, look at this. Same average. By doing the average, calculate H1, H2, 2 to 3 condensation, 3 to 4. Here, now we need to calculate the dryness fraction. Okay? Now here, in numericals, they have not asked till date, means only 2 insems are happened. अभी तक कितने insem हो गए? Only 3. Sorry, only 2. This is the third insem. In 2 insem, they have not asked numericals on the multi-expansion. They have asked only on the individual expansion. Right? If if there is a multi-expansion wall, there is one more factor, that is the dryness fraction. Okay. Now here is the dryness fraction x4, and here is the x6. Now here we require only x4 here, dryness fraction at this point. Okay. Now how it differs? Just look at this. M1 evaporator 1, M2 evaporator 2. Now M1 is what? Mass circulated in evaporator 1. And M2 is what? Mass circulated in evaporator 2. Okay. Now see here, mass circulated in evaporator 2 is M2. That is equal to how much? That is equal to mass supplied from this expansion wall plus during this expansion wall. Which expansion wall? This. During this expansion wall of evaporator 1. Expansion मध्ये काय होतं? What is the input of expansion? Liquid. After expansion, pressure reduces and some of the refrigerant evaporated and it carries latent heat. That's why remaining refrigerant temperature is reducing. Evaporative cooling, right? Same cooling, same principle that is used in the earthen pot. तुम्ही उन्हाळ्यामध्ये डेरा उघडल्यानंतर काय दिसतं तुम्हाला? वेपर दिसतात, वाफ दिसते. पाणी थंड असतं पण वाफ असतं. तुम्हाला वाटेल की असं कधी वाटलं गेलंय इथून तर वाफ निघते पण पाणी गार आहे. त्या वाफेमुळेच पाणी गार आहे. Why? Because this has absorbed the latent heat. That's why temperature is reduced. Same thing is happening. But here, what is the catching point? You forget all those things. Whatever the vapors produced during this expansion, that some of the vapor is sent to the evaporator 2. This does not take part in the refrigeration process. Refrigeration process मध्ये हे vapor part घेत नाही. Because already it is evaporated. It will not take part in the refrigeration, but it will take part in the compression process, right? So here you can see that M2 is what? Mass of the refrigerant that is circulated in here in evaporator 2. That is this plus M1 into x4 divided by 1 minus x4. x4 is what? Dryness fraction at this 0.4. Right? This is the only difference. Remaining you can write down power formula, CO2 formula. That is only explained. Okay? Then next, individual compressor, multiple expansion. Now here individual compressor we are using. Look at the diagram of individual compressor. Individual compressor means what? For each evaporator. See here. As per syllabus, I have made all the PDF, right? Additionally, out of syllabus, they may ask individual compressor, individual expansion wall. In that case, accordingly you make the changes. Individual compressor means what? Separate compressor is used for separate evaporator. That's why individual compressor, right? And multiple expansion. Look at the position of expansion wall. Multiple expansion. Wherever there is a multiple expansion, for the second expansion, inlet is always liquid. That's why this 7 to 8, right? Pay attention here. Stop your discussion. Huh? Look at the individual compressor. 3 to 4 individually compressed. 1 to 2 individually compressed. Output of evaporator 1 is what? 3. That is individually compressed from 3 to 4. Output of evaporator 2 is what? 1. That is individually compressed here. So total work is how much? P1 plus P2. That is area of this triangle plus area of this entire triangle. Then now in individual compression, both compressor output have the same pressure. And then these are sent to the condenser from here. Then these are sent to the condenser here. Then 6 to 7 expansion, then second expansion and evaporation. And cycle repeats. right? Here you have to write what is Q1 and Q2, loads on evaporator 1 and 2, ME1, what is ME1? Mass of refrigerant circulated in evaporator 1, that is equal to M1. Formula is 210 Q1 divided by H3 minus H9. Look at this, H3 minus H9. M2 is what? Mass of the refrigerant circulated in evaporator 1, and that is for refrigeration process only. M2 is what? Mass of the refrigerant that is circulated in the evaporator 2, and this is the mass only that will take the part in refrigeration process. Okay, that is 210 Q2 divided by H1 minus S7, right? M2 dash is what? Mass of the refrigerant that is evaporated in the expansion wall 1 but sent into the evaporator 2 but does not take part in the refrigeration process but take the parts in the compression process, right? समजलं का? खरं सांगा समजलं का? हा? काही जणांना जरी नाही समजलं तरी ते डायग्राम तरी बघा ऍटलिस्ट. हा? ओके? Me2 is what? Mass of the refrigerant that is circulated in evaporator 2. But entire mass does not take part in refrigeration process. Only this mass takes parts in the refrigeration process because it is cold one. Okay? That is M2 is equal to M2 dash, that is equal to this. Okay? Now this P1 for power we are taking the Me1 and Me2, that is the total mass, and for refrigeration we are taking only M1 and M2. Remember this. Okay? For numericals. Then refrigeration process, COP, this. Understood this?
Yes.
Now last, individual compressor with compound compression and flash interval. Compound compression म्हणजे काय? फर्स्ट कॉम्प्रेस मध्ये कॉम्प्रेस करायचं, त्यानंतर फ्लॅश इंटरकूलिंगचा ऍड होणार, सेकंड इव्हॅपोरेटरचा ऍड होणार, कंबाइनली दॅट इज सेंट टू द सेकंड कॉम्प्रेसर. दॅट्स वाय द नेम कंपाउंड कॉम्प्रेशन. Okay? Now look at this, evaporator 1, output sent to the compressor 1, then flash intercooling is there. Okay? With flash intercooling is sent here. As whenever there is a flash intercooling or liquid intercooling, output of intercooling will be saturated vapor, guaranteed, right? So look at the diagram. This output of intercooling is what? Saturated vapor, right? That is your 3. Now here output from flash chamber 3A and output from evaporator to 3B. These are combining at point 3 and combinedly they are sending it to the compressor 2. Right? आता मी एक क्वेश्चन विचारतो तुम्हाला. Mass of the refrigerant sent to the compressor 1 is what? Mass output mass of the evaporator 1. Right? Now here that is your MC1. MC1 is what? Mass of the refrigerant circulated in the compressor 1. And that is equal to M1. M1 is what? In evaporator 1. Evaporator 1 मध्ये जेवढं सर्क्युलेट होतं तेवढंच compressor 1 मध्ये सर्क्युलेट होतं. That's why MC1 is equal to M1. Right? That is equal to 210 Q1 divided by H1 minus H8 as per this. Okay? Now all these details I have written here. Now M2 dash is what? Mass of the refrigerant evaporated in flash intercooling during the heat exchange process. Right? That can be calculated as MC1 into, look at this, H2 minus S3 divided by H3 minus S6. This formula you required for numericals. Okay? And MC2 is what? Mass of the refrigerant circulated in second compression, which is equal to MC1 plus M2 plus M2 dash. Here dash is remaining. Here dash is remaining. Okay? MC1 plus M2 plus M2 dash. That is for compressor 2, output of compressor 1, output of evaporator 2 plus mass evaporated in the
Flash
intercooler, right? P1 for P1 MC1 H2 minus H1 divided by 60, and for P2 MC2 into H4 minus H3 divided by 60. Total power P1 plus P2. Refrigerating effect, this COP. This. Understood?
Yes, sir.
Right?
Yes.
Now last 2 minutes. What is this? Cascade system. Now why we are going for cascade system? Because limitations of, right? तुम्ही कोणताही सिलेबस बघा, कोणताही युनिट बघा, जे पहिले पॉइंट शिकता त्यात लिमिटेशन असतात, म्हणून दुसरे पॉइंट, त्यात अजून लिमिटेशन्स असतात, म्हणून तिसरा पॉइंट, राईट? तुम्ही ऑब्झर्व केलंय का? दॅट इज हाऊ द सिलेबस इज डिझाइन. सो हियर वाय थर्ड पॉइंट लिमिटेशन्स इन द second point. Why second point? Limitation in the first point, right? So limitation of multipressure system is what? High, same refrigerant should have the high boiling point and low freezing point. Such refrigerants are rarely available, right? And for low freezing means for achieving the low temperature, we have to reduce the temperature to very low limit, right? So as we are reducing the temperature, if you remember, I have already told you that to reduce the temperature, if we are reducing only pressure, look at here. Someone is discussing here, sometimes I have a discussion. Last 2 minutes, listen carefully. See here. If we are reducing temperature just by reducing the pressure, we can reduce it. You reduce the pressure again and again, then you will get the low temperature. But what is the point here? Specific volume increases. Means what? That refrigerants required more space. Okay, so its compressor work also increases. That's why we are going for cascade system. In cascade system, 2 separate systems we are combining. 2 separate refrigerants we are using: ammonia and CO2. Okay, ammonia and CO2. You can clearly see here. This is the schematic diagram. Upper diagram is of NH3. Okay, now NH3 is toxic, that we cannot use directly for the food, but CO2 is not toxic, and CO2 is very good refrigerant on the lower temperature side, and NH3 is very good refrigerant on higher pressure side. It has very good thermodynamic properties on higher pressure side, ammonia. Okay, that's why on higher pressure side we are using ammonia, and on lower temperature side we are using CO2, right? VCR cycle of ammonia we are combining with the VCR cycle of CO2, right? Now suppose I want here minus 80 degrees centigrade temperature. Okay, so we are combining evaporator of ammonia with condenser of CO2, right? Now suppose by this VCR cycle at the evaporator of ammonia, if we are getting the minus 20 degrees centigrade temperature, so what, suppose effectiveness is considered effectiveness is 100%. So what will be the condenser temperature of this CO2? Minus 20, right? But this condenser has minus 20 degrees centigrade temperature as well as high pressure, right? Low temperature, high pressure. This is the fantastic opportunity, right? If opportunity is there, what we need to do? Expand, because high pressure. If we will expand this, further temperature will reduce, and here we can get the minus 80 degrees centigrade temperature, right? That's why cascade system is preferred over multipressure system, right? Firstly, it is developed by Nestle Food. Okay, and this is the pH diagram. Same pH diagram. You can write down here: compression, condensation, expansion, evaporation, condenser, CO2, NH3. Okay, explain these processes. Write down CO2 advantages and NH3 advantages. Right? Okay. Now follow these instructions. Do study previous question paper numericals I have solved.